Hello everyone, in this video we'll discuss about the virtual memory. Virtual memory is a system of feature that utilizes both hardware and software to mitigate the limitations of physical memory. This approach allows the computer to execute larger application or multiple programs simultaneously without being constrained by the physical memory capacity. So this is the diagram of the virtual memory. So the middle part is a virtual memory and the left part is our application program or user, and this is the RAM and this is the server. So the process starts from the it goes from the application to the virtual memory and then passes to the RAM and different servers as well. So the basic concepts are the virtual address space and the paging and swapping. So the virtual address space is nothing but an abstract of a larger continuous memory space for each process, which is called as the virtual address space. Paging is nothing but the operating system organizes virtual memory into fixed units known as the paging. Swapping is nothing but when physical memory is full, the OS can move inactive pages from RAM to space on the hard drive or SSD called the swap space. So these are the some importance: increased memory availability, isolation and security, multitasking and program size. Virtual memory allows the system to exceed physical memory limits by swapping pages in and out of physical memory. Isolation: each process has a unique virtual address which prevents it from accessing other processes memory, thereby improving security and stability. Multitasking: virtual memory enables the operating system to run multiple applications by efficiently managing all allocated memory to each process. Program size: or developers can write program without being constrained by physical memory limits, as a virtual memory supports the execution of program need for more than its physical availability. The effective use of the physical memory, demanding paging, paging replacement, memory over commitment, shared libraries and copy on write. Demand paging: only the necessary pages of process are loaded into the physical memory. If a needed page is not a memory, the page fault occurs, prompt the OS to load the required page itself. When the physical memory is full, the OS uses algorithms to decide which page to swap out to the disk, which is called the page replacement algorithm. Memory over commitment: the OS can allocate more virtual memory to process than the available physical memory, assuming to not all allocated memory will be used simultaneously. Shared libraries: multiple processes can be used the physical memory for common code such as libraries, which reduces overall memory usage. So copy on write: when a processor duplicates a portion of its memory, like with the fork system call, the OS or initially shares the page between the original and the new processors. Okay, so this is the physical memory. So this is OS memory, monitoring camp, and the OS memory, which consists of all the memory when the data is passed through it. Cache memory. So cache memory is a small, high-speed storage situated near the CPU. It holds frequently access data and instructions, enabling the CPU to quickly retrieve the information without accessing the main memory. This significantly accelerates the computer overall performance time. So this is the CPU and this is the cache memory, which is between the main memory and the CPU. Role of the cache memory reduces access times, since cache memory is much faster than the main memory. It reduces the time from the CPU to retrieve the information, minimizing latency by storing frequently used data closer to the CPU. Cache memory reduces the latency associated with the fetching data from the slower main memory. Improving throughput: faster access to data enables the CPU to process more instructions in each period, increasing the overall throughput of the system. Enhancing CPU efficiency: by minimizing the waiting time of the data retrieval, the CPU can focus more on processing tasks, thus operating more effectively. So there are three types of cache: L1, L2, and 3. So this is a CPU, L1 cache, L2 cache, and the main memory. So this is in between the CPU and the main memory. So L1 cache located integrated directly into the CPU chip. Fastest among the cache levels. Smallest type ranging from 2 KB to 64 KB. Function stores the most frequently accessed data. L2 cache, which is located either on the CPU chip or on a separated chip close to the CPU. Slower than L1 cache but faster than the L3 cache and main memory. The size is larger than the L1 cache, typically ranging from 256 KB to several MBs. Function act as secondary cache, storing the data instructions that are not frequently accessed and as those of L1 cache but still need to be retrieved quickly. L3 cache located shared among multiple CPU cores and located on the CPU chip. Speed slower than L1 and L2 cache but faster than the main memory. Size which is typically between the MB several MBs to tens of MB. The main function of it is to it stores the data that is less frequently accessed that the data in L1 L2 cache but still benefits for the faster access and the retrieves from RAM. So in this video we have learned about different cache levels L1 L2 and L3 and what is cache memory, and also we have learned about the virtual memory and what are the basic concept and importance of the virtual memory. Thank you so much.